Assalamu alaikum and hello everyone. We are group 4 from the telecommunication course and we will be talking about pulse coding and multiplexing. In the past, back in the 70s to 80s, when telephone technology was still young, users will have to enter a specific number of the receivers and repliers. It's also said number is passed to a building called the central office, where a professional receives the number and physically connects the wire from caller's channel to the receiver's channel port. However, there was a problem with this technology, as the numbers of users or subscribers of the network increased more and more, cable and wires were needed, and there was a tremendous increase in number of active users and calls. Simply, but put the manual switching on the physical wire technology were running out of capacity and were getting costly. If we continue to use this technology, we suffer the disadvantages of manual switching. So the disadvantage of manual switching would be expensive and needs a lot of planning, hard to maintain, prone to human mistakes in the manual switching process, and already allows limited number of users. The solution to this was research and develop a digital switching system. This will allow to reduce the amount of copper required. Whatever the new system is, the development will need to focus on easy to upgrade, suffice the market's needs and user desires. And for comparison of manual with digital, the effect will convert this big building to this small room, which was a huge improvement at the time. And this is a map of current problem, so let's analyze the problem at the hand. We have several users. We will call each one on a channel that are trying to contact other channels only through voice. We have a problem if using several wires for the same process, which want to simplify or unify the engineers. At the same time, research and developed 3 ways of handling several users at one time called multiplexing. Multiplexing is a process of transmitting 2 or more signals at the same time. And that's a flowchart of multiplexing, which we will discuss the FDM, which frequency division and MUX, TDM, which is time division MUX, and at last SDM, space division MUX, which is another method that is basically the optical fibers. This technology is not suitable for the scale as it involves a lot of wire and would be very expensive. Now let's go back and discuss FDM. Imagine you want to go from city A to B. Arguably, you could go by walking, cycling, or even riding a car, or a bus, or even a train, or by plane. However, only few methods will stand out when we consider cost, time, and energy. And lastly, distance or landscape obstacle. If we reimagine you as only one signal, we call this process of preparing signal to travel from city A, the transmitter, to city B, which is modulation. And modulation is a process of preparing a signal to travel in a transmission medium. Receiving said signal is called demodulation. Ultimately, the method of modulation process is outside the scope, but this concept is what FDM. Typically, and for the FDM, typically speaking a voice signal in our problem is about 4 kHz maximum. We modulate each channel's input into a single signal that has multiple frequencies that are then demodulated at the receiver. However, there is a problem going back to the traveling analogy. The numbers of people talking a method is limited. In a telecommunication sense, the number of users at the same time is extremely limited. And the second method of multiplexing is called TDM, compared to FDM, where we are sending several users input information signal at the same time. We cut the signal into several pieces in TDM. Said pieces are codes in 0 seconds and 1 seconds. A 1 or a 0 is called a bit. To simplify things, imagine if each channel's message is made out of 5 random bits. We take the first bit from each channel to form group 1 and then send them over. The group taken each period of the time is called a frame. We then take the next bit from each user to form frame 2 and send over again. We repeat the process to form frames 3, 4, and 5 in the same pattern. At the receiver, which is aware of how many bits we are talking, it will decode the received code and send to the specified channel. The messages have been sent and received. In real life, each frame is made out of 32 channels. Each channel of a user is made of n bits. This means that in one frame we are sending 32 bits. However, to increase the capacity per user and to prevent hacking, we specify 2 channels, particularly channel 0 and channel 16 for synchronization and signaling process respectively. However, there's a small problem in our TDM idea. The users aren't taking in zeros and ones. We say their message is analogous and needs to be converted to a digital form of zeros and ones. This is the difference between FDM and TDM, where in TDM we require digital input. To solve this dilemma, we bring a concept called PCM, or pulse code modulation. So for PCM, our problem is as follows. We are designing a device that would convert the analog to digital signal. Conventionally, it is called analog to digital converter, or ADC for short. Said convergence consists of 3 processes. 1. Sampling, which is to take a sample from the signal's amplitude, where the sampling should not be very complicated, but also enough to be able to draw the signal. 2. Quantization, which is rounding the sample. And last, coding, which is converting the quantized samples to a bunch of ones and zeros to be read at the receiver. First things first, human ear can hear frequencies from 20 Hz to 20,000 kHz. We only need to encode enough to make a reasonable digital reproduction of the voice in our telephone. A typical voice signal has a frequency of up to 5 kHz. And for sampling, sample rate is the number of samples of audio taken per second, measured in hertz, and the goal is to make the sample rate as low as possible without losing the signal. A physicist named Harley Nyquist, born in 1889 and died in 1976, created what is known today as Nyquist sampling frequency. The theorem goes as follows. To ensure no information is lost in the sampling rate must be at least 2 times the max frequency. And for quantization and coding, the process of encoding a sample is called quantization. To be able to quantize the samples, we first have to specify the digital representation of the samples. Bit depth is the number of bits information in each sample. The difference between the original signal and the processed signal is called quantization error. To summarize the 3 processes, here is an example simulation done in MATLAB. This specific type of PCM is called PEM, pulse amplitude modulation. However, there are many other types. Going back to our map, where each channel is 8 bits, then we require each quantized sample be represented by 8 bits. We have a voice signal of 4 kHz, where Nyquist theorem dictates we sample at least in double that. In conclusion, we design a PCM that samples 2 multiply 4 kHz multiply 8 bits, which at least giving us 64 kilobytes, where we could sample more, but in telecommunication frequency is a source, meaning that we do not want to use unnecessarily. And going to ethical and global issues in telecommunication. Now that we have showed how digital fixed telephone technology developed, we want to discuss another topic, particularly the ethical and global issues in telecommunications. The current society is a surveillance society, ranging from being monitored on closed-circuit television cameras in the inner city to the use of loyalty codes. The authors do acknowledge that the surveillance society has its benefits, but that it has negative consequences, such as abuse by governments or accessing private data. And for the health issue, there is a little information about possible health effects from localized reference exposures or about the effects of different pulsing regimens that RF fields are used in mobile telecommunications. And for digital divide, interaction between human and new communication technology has increased significantly. Since 1875, people started using phone, and the phone technology evolved to highest peak with the 25th century. However, not everyone has access to this technology. The idea of the digital divide refers to the growing gap between the underprivileged members of society, especially the poor, rural, elderly, and handicapped portion of the population who don't have access to computers or even the internet, and the wealthy middle class and young Americans living in the urban and suburban areas who have access. This video was made possible by the group members, and thank you.